The universe does not speak. It does not explain. It simply exists, silent and governed by invisible laws. For millennia, humanity tried to understand its origin and purpose through myths, symbols, and sacred narratives. We painted gods in the stars and heard divine whispers in the wind. We sought comfort in stories that gave meaning to our fleeting existence against the backdrop of an eternal, unfeeling cosmos. But in the 20th century, a new language began to decipher the cosmos: mathematics. This language, precise and universal, allowed us to read the universe's own script. Among those who dared to translate the universe into equations, one name stood above time itself. A mind confined to a chair, but whose thoughts roamed the very fabric of reality: Stephen Hawking. This is the story of his intellectual journey, a quest not just for the secrets of the cosmos, but for the very nature of knowledge itself. Stephen Hawking was born in an era marked by profound scientific transformations, a world still reeling from the discovery of relativity and the dawn of the atomic age. From an early age, he showed a fascination not with the mundane, but with the most fundamental questions a human can ask. Where did the universe come from? Did it have a beginning? And perhaps most chillingly, will it have an end? These weren't idle curiosities for him. They were the central puzzles that would define his life's work. While many of his contemporaries and predecessors sought answers in ancient traditions or philosophical doctrines, Hawking chose a different, more arduous path. He believed that the deepest truths of existence were not hidden in sacred texts, but were encoded in the universal natural laws that govern everything, from the fall of an apple to the dance of distant galaxies. His quest was to understand the cosmos through its own rules, a pursuit that would redefine the boundaries of science. Modern cosmology, building on the revolutionary ideas of Einstein, transformed the universe from a divine stage into a scientific object, a dynamic and evolving system that could be studied and understood. Space and time were no longer passive backdrops for cosmic events. They became active participants, warped and shaped by mass and energy. Hawking, with his extraordinary intuition, understood that to truly explain the universe, he needed to bridge the two great pillars of modern physics. On one side stood Einstein's theory of general relativity, the epic saga of gravity, planets and galaxies, which describes the universe on the largest of scales. On the other was quantum mechanics, the strange and probabilistic world of particles and fields, which governs the universe at its smallest, most fundamental level. So the challenge was monumental, a true clash of titans. These two incredibly successful theories seemed utterly incompatible. They spoke different languages and described two different realities. For Hawking, uniting them wasn't just an academic exercise. It was the only way to answer the ultimate question of our origins. For centuries, the origin of the universe was inextricably linked to supernatural narratives, a divine act, a moment of creation by a conscious, external agent. This idea provided comfort and a sense of purpose, but Stephen Hawking, working with his colleague James Hartle, proposed something truly radical. The universe could have arisen spontaneously from the laws of physics alone. In their no-boundary proposal, the universe didn't need a creator to light the fuse of the Big Bang. According to this view, if you rewind the cosmic clock, you don't reach a single definitive starting point, a moment before which time itself did not exist. Instead, as you approach the beginning, the distinction between time and space blurs and dissolves. Time wouldn't require a starting point defined by divine will because, in a sense, it had no beginning. The cosmos could simply exist, a self-contained system obeying eternal mathematical rules, emerging from nothing in a quantum fluctuation. This idea was a profound shift, moving the question of creation from the realm of theology firmly into the domain of physics. The greatest, most daring ambition of modern physics is to find a single, elegant equation capable of describing all the fundamental forces of the universe: gravity, electromagnetism, and the nuclear forces. Hawking famously called this the theory of everything. It represents the ultimate holy grail for physicists, a final theory that would unify all of physical reality into one coherent framework. But for Hawking, this was not merely a scientific achievement to be celebrated in academic halls. It was a deeply philosophical one. A theory of everything would be the culmination of centuries of human inquiry. It would answer the deepest question ever asked: Why does the universe exist the way it does? By these specific laws, these particular particles, this unique arrangement of space and time? Knowing this theory, Hawking once mused, would be like knowing the mind of God. It would represent the ultimate triumph of human reason. Contrary to what many believe, Stephen Hawking did not reject philosophy. In fact, he engaged with it deeply, often challenging its traditional role in the modern world. He argued that science, particularly theoretical physics, had taken over the torch from philosophy in the quest to answer the big questions about reality. Where philosophers once relied on logic and reason alone, scientists now had a more powerful tool: the scientific method. With its cycle of hypothesis, prediction, and experimental verification, he believed that modern science had assumed part of philosophy's ancient role to explain reality without resorting to preconceived notions or dogmas. For Hawking, the universe did not need a moral purpose or a grand narrative to be meaningful. It needed only to be mathematically coherent and consistent with observation. The beauty he saw was not in a divine plan, but in the intricate, elegant logic of the physical laws that brought the cosmos into being and governed its evolution. By stating that the universe can explain itself through the laws of physics, Stephen Hawking inevitably sparked a global debate, one that resonated far beyond the scientific community. His statements were often interpreted as a direct assault on religious belief, but his true intention was more nuanced. It was not about denying personal beliefs or the comfort they may bring, but about establishing clear and necessary boundaries between different ways of knowing. In his view, science's domain is to describe how the universe works, based on evidence, observation, and testable models. Beliefs, on the other hand, belong to the individual and spiritual realm, addressing questions of meaning and morality that science is not equipped to answer. In modern science, there is no place for dogmas or untestable assertions. There are only hypotheses, rigorous tests, and the ever-present possibility of being proven wrong by new evidence. This commitment to intellectual honesty is the bedrock of scientific progress. Stephen Hawking did not leave us with final, definitive answers. His theories are still debated, tested, and refined. Instead, he left us something far more powerful and enduring: a method. He embodied the courage to ask the biggest questions, the intellectual discipline to perform the complex calculations, and above all, the profound humility to stand before the vast, silent unknown. He taught us that the goal of science is not to eliminate mystery, but to engage with it on its own terms. The universe remains silent. It does not reveal its secrets willingly. But now, thanks to minds like Hawking's, we know how to listen to it. We listen not with our ears, but with our telescopes, our particle accelerators, and the elegant, powerful language of mathematics. The quest continues, and his legacy is the endless horizon of questions that still lie ahead. If you enjoyed this journey through the cosmos and the mind of a great thinker, please like the video, share it with others who love science and philosophy, and subscribe to the channel to continue exploring the greatest mysteries of the universe with us. Thank you for watching.